Quick headlines before the intro. Today is June 10th, and the cleanest signal is this: AI tools are getting faster, less confusing, and more operational. Google released DiffusionGemma, an open experimental model that does text generation differently. Instead of producing one token after another like a normal autoregressive language model, it generates blocks of text in parallel and refines them, which Google says can be up to 4 times faster on dedicated GPUs. OpenAI updated ChatGPT's model picker so regular users do not have to stare at a wall of model names. The new choices are more like effort levels: instant, medium, high, extra high, pro standard, and pro extended. GitHub shipped an experimental command in Copilot CLI called Security Review, which checks local code changes for high-confidence security issues before they become production problems. Copilot Chat can now see agent sessions too, so you can ask what an agent changed, what it validated, and where it left off. And over on Hugging Face, Pollen Robotics published the media stack behind Reachy Mini: camera, microphone, WebRTC, GStreamer, local apps, browser apps, and GPU-backed spaces. Short version: the flashy part is the model. The serious part is the workflow around it. Receipts up. Hype down. Let's lock in.
Powered by artificial intelligence.
Story 1 is DiffusionGemma, and this is the one that deserves the thumbnail. Most language models work like a person typing under pressure: one token, then the next token, then the next. That approach is powerful, but it also means the model keeps loading weights and stepping forward in sequence. Google is testing a different route. DiffusionGemma starts with a block of placeholder tokens, then repeatedly refines the whole block in parallel until the text snaps into shape. Google says DiffusionGemma is built on the Gemma 4 backbone and released under an Apache 2.0 license. It is a 26 billion parameter mixture of experts model, but only about 3.8 billion parameters are active during inference. That active parameter number matters because it is what makes local deployment more realistic. In the developer guide, Google says quantized deployment can fit within 18 gigabytes of VRAM limits, and the model is designed for developer workflows where latency is the enemy. The performance claim is eye-catching: up to 4 times faster token generation on GPUs, with examples of 700 plus tokens per second on an RTX 5090 and 1000 plus tokens per second on a single H100. Do not hear that as every laptop is suddenly a supercomputer. It means the architecture is trying to move the bottleneck. Instead of being mostly memory bandwidth bound like many local autoregressive models, the workload becomes more compute-heavy and parallel. That is interesting because modern GPUs are very good at parallel work. If this style matures, local assistants, code editors, fill-in-the-middle tools, and real-time writing interfaces could feel much snappier. Here is the human version of why diffusion text is weird in a good way. A normal left-to-right model is brilliant, but it can paint itself into a corner. If it starts a structured answer badly, everything after that has to work around the early mistake. DiffusionGemma gets to look across a whole canvas during generation. The developer guide calls this bidirectional context and self-correction. The model can use information from multiple positions at once, then refine uncertain tokens again. Google uses Sudoku to make the point. Sudoku is annoying for left-to-right generation because every number depends on rows, columns, and boxes. You cannot really solve it by confidently filling one character at a time without caring about the future. Google says its base model is not trained to solve Sudoku, but after a simple supervised fine-tuning recipe, the tuned model reaches 80% correctness and uses fewer inference steps because it can stop earlier. The point is not that we needed another AI Sudoku champion. The point is that some tasks have global structure. Code formatting, table repair, template filling, markdown cleanup, puzzle-like reasoning, and inline editing all benefit when the system can see the whole shape at once. Now, the caution. This is experimental. Diffusion-style text generation needs different sampling behavior, different serving support, and different developer intuition. It will not automatically beat every autoregressive model on every writing task. But it gives open model developers a new direction to explore, not just bigger models, but different generation mechanics. Story 2 is smaller, but every ChatGPT user will feel it. OpenAI updated the ChatGPT model picker. Instead of asking users to understand a bunch of model labels and thinking modes, the picker now uses simpler choices: instant, medium, high, extra high for Pro plans, Pro standard, and Pro extended. On mobile, the picker sits at the top of the conversation. On web, it appears directly in the message composer. This is not just a cosmetic update. Model choice has become one of the most confusing parts of AI products. Most people do not wake up thinking, "Today I need a specific hidden model variant with a specific reasoning budget." They think, "I need a fast answer," or "I need the model to slow down and think harder." OpenAI is moving the interface closer to that mental model. There is also an auto-switch setting. Users can decide whether instant should automatically move to medium when a request needs more reasoning. That is a nice compromise. Some people want the system to handle routing quietly. Others want control, especially when speed, limits, or predictability matter. The old names map into the new levels too. Thinking standard becomes medium, thinking extended becomes high, thinking heavy becomes extra high, and thinking light is removed. The bigger lesson is simple. If model companies want mainstream users, the interface cannot feel like a GPU menu at a cloud conference. Story 3 is not a product feature. It is the messy political layer around AI. OpenAI published a report saying it banned 2 clusters of ChatGPT accounts likely originating from China after they used its models in apparent covert influence operations. According to OpenAI, one campaign generated social media comments and images claiming AI data center buildouts were raising electricity prices for average families. OpenAI called that cluster data center bandwagon. The second cluster generated comments and images criticizing United States tariffs as attempts to dominate technology competition. And OpenAI says prompts told the model to avoid including China's leader Xi Jinping and instead include President Trump. Why does this matter for a tech channel? Because the public fight over AI is no longer only about benchmark scores. It is about data centers, electricity bills, jobs, tariffs, national policy, safety, and who gets blamed when things feel expensive or unfair. Those are real issues, and people should debate them. But influence operators love real issues because real issues already have emotional fuel. OpenAI says it found no evidence of meaningful breakout beyond the activity itself. That is important. We should not inflate the story into panic. But the direction is clear. AI tools can help generate cheap, targeted political content, and AI companies are going to keep publishing takedown reports as part of their trust and safety work. The uncomfortable takeaway is that AI debates are now targets. If a topic affects money, infrastructure, national security, and public trust, somebody will try to manipulate the conversation. Story 4 is GitHub's new security review command for Copilot CLI. The command is /security review, and GitHub says it is shipping as an experimental public preview feature. The idea is straightforward. While you are still in the terminal, before your changes go anywhere near production, you can ask Copilot CLI to scan the current code changes for security problems. GitHub says the command returns high-confidence findings scored by severity and confidence, plus suggestions you can apply without leaving the terminal. It is tuned for common high-impact vulnerability classes, injection flaws, cross-site scripting, insecure data handling, path traversal, and weak cryptography. That list is practical. It is the stuff that keeps showing up in real bug reports. The important caveat is that this is not GitHub code scanning. It does not rely on CodeQL, Dependabot, or secret scanning. GitHub frames it as a complement, a lightweight, on-demand review before commit. That is the right mental model. Think of it like a quick security sniff test, not a full audit. It might catch the sharp object on the floor before you step on it. It does not mean the room is safe forever. For AI coding, this matters a lot. Agents can write code fast. Humans still need confidence that fast code is not quietly introducing obvious vulnerabilities. A terminal native review step is a good place to add friction, because it catches the developer at the exact moment the code is still cheap to change. GitHub also improved the handoff between Copilot Chat and Copilot Cloud Agent. If you ask Chat to create an agent session, create a pull request, or do deep research on a repository, Chat can now reflect the status of that in-progress session. Once the session is complete, you can ask follow-up questions about what happened or start another session from the same conversation. Two tools matter here. Get Agent Logs lets Chat pull in logs from a Copilot Cloud Agent's work on a pull request, so you can ask what changed, what got validated, and why the agent made a choice. Session Search lets you find and summarize past agent sessions by topic, title, or recency. That sounds small until you have multiple agents working across a codebase. Without memory of the work, every session becomes a mystery box. With logs and search, the agent leaves a trail. This is the boring feature that makes agents more usable. If an agent touched 20 files, ran tests, backed out one idea, and opened a pull request, you need a way to ask, what actually happened here? Not in a separate log viewer. Not by spelunking through files. In the same chat where you are already coordinating work. GitHub also raised the enterprise cost center limit from 250 to 500. That sounds unrelated, but it fits the same pattern. AI developer tools are becoming managed infrastructure. Enterprises need visibility into agent work, security review, and spend allocation. The agent era is not just about smarter assistants. It is about tracking what those assistants do. Last story, Reachy Mini's media stack. This is a good change of pace because it pulls AI out of the chat box and puts it into a small robot with eyes, ears, and a voice. Pollen Robotics published a detailed Hugging Face post on how Reachy Mini handles camera and audio. Both the light and wireless versions can be used locally or remotely, and the goal is that the same code works in each case. The hardware is practical: a Raspberry Pi camera 3 wide, microphones, a speaker, acoustic echo cancellation so the robot does not hear itself talking and get confused, and direction of arrival support so it can know where sound is coming from. The software stack uses GStreamer and WebRTC. GStreamer handles media pipelines. WebRTC handles low-latency streaming, the same basic family of technology browsers use for video calls. The neat part is where the compute can live. A local app can read camera frames directly. A browser app can connect over WebRTC and run models with WebGPU. A Hugging Face space can handle heavier GPU tasks, like object tracking, then send control data back to the robot. The post also talks about latency and reports around 100 milliseconds in one local network test with a Reachy Mini wireless and a JavaScript app in Chrome on Windows. Why include this in an AI news episode? Because it shows the shape of physical AI. The model is only one piece. You need sensors, audio, low-latency streams, browser bridges, local privacy paths, remote compute paths, and control loops that do not feel sluggish. That is where the next wave gets interesting. Here is the watch list. First, watch DiffusionGemma. If developers can serve it easily through VLLM, quantize it cleanly, and build good local editing workflows around it, text diffusion could become more than a research demo. The test is not just tokens per second. The test is whether it makes real tools feel better. Second, watch the model picker trend. OpenAI is simplifying because users are tired of decoding model names. That is good. But there is a balance. If the picker hides too much, power users may feel they lost control. The best version gives normal users simple choices and advanced users a way to see what is happening. Third, watch GitHub. Security review in Copilot CLI, agent session logs, session search, cost centers, third-party agent validation from yesterday, and NPM v12 defaults all point in the same direction. AI coding tools are becoming a managed system. The value is speed. The risk is invisible change. The fix is logs, review, policy, and ownership. Fourth, watch physical AI. Reachy Mini is not just cute hardware. It is a reminder that real-world AI needs media plumbing. If the camera feed is late, the robot is dumb. If the microphone hears the speaker, the robot is confused. If the app has to send everything to a remote GPU, privacy and latency become part of the product. That is today's signal. Faster generation from Google, clearer model choices from OpenAI, safer agent workflows from GitHub, and a more practical robot stack from Hugging Face and Pollen. Full source links are in the description, and every short from this episode should point back here for the full receipts.